Hello, dear students. You're welcome to RK Institute. I am Dr. RK Seni, and to continue the elimination reaction today, I am going to discuss beta elimination. Beta elimination are those reactions in which removal of leaving group and deprotonation or other atom or group from adjacent carbon atom. These reactions are also known as alpha beta elimination, or also known as 1-2 elimination in old conversion. Alpha beta elimination or only beta elimination reactions. In such type reactions, leaving group and deprotonation takes place from adjacent carbon atom, and hence are known as beta or 1-2 elimination or alpha beta elimination also. On the basis of their mechanism, there are three types, mainly three types. In first cases, if leaving group leave first from the substrate, in case first, if leaving group leave substrate first, then formation of carbonium ion takes place in step first, and then deprotonation takes place. Such type reactions are known as E1 reaction. Such type reactions are known as unimolecular elimination, because the rate of reaction depends only upon the concentration of substrate, because after removal of leaving group, they change into the carbonium ion, E1. In second case, if removal of leaving group, and deprotonation are simultaneously takes place, removal of leaving group and deprotonation are simultaneously takes place. In this case, the partial double bond character develop in the transition state, and these reactions are known as E2 elimination. On the basis of alkene character, we decide major product as well as rate of reaction. And in third cases, these reactions are known as E2. And in third cases, deprotonation takes place first. And then a removal of leaving group. If deprotonation takes place first, then formation of carbonium ion, and such type reactions are known as E1CB. Carb anion, on the basis of the stability of carbon ion, they give major product, and mainly these alkenes are known as Hofmann alkenes. And hence beta eliminations are namely three types, particularly E1, E2, and E1CB. And what conditions and what nature of substrate by which they undergo different kind of beta elimination, like as E1, E2, and E1CB. Today, I am going to discuss particularly E1 mechanisms. For the E1 mechanism, what conditions for reactions or for substrate by which they undergo elimination 1 or unimolecular elimination. In E1 reaction, elimination 1, जिसे आप कहते हैं यूनिमोलिकुलर elimination. It is two-step mechanism. In step first, leaving group leave the substrate and change into the carbonium ion or carb cation. And in step second, deprotonation takes place. Therefore, we added base by which deprotonation takes place, and hence the carbonium ion change into stable alkene. By the use of base, deprotonation takes place in step second. Therefore, step first is slow and known as RDS, because more stable substrate change into unstable carbonium ion, and hence such reactions, such steps are slow steps and are known as rate determining step, RDS. On the basis of RDS, the rate of reaction is directly proportional to the concentration of substrate power 1, and hence they are unimolecular and first order elimination. The rate of reaction depends upon following factors. The rate of reaction depends upon following factors like as nature of substrate, nature of substrate. As we know, after removal in step first, leaving group leave from the substrate. Therefore, if leaving group present at the tertiary carbon, then easy elimination takes place because they generate carbonium ion. And as this leaving group present at the tertiary carbon, then reaction will be fast. The rate of substrate toward the elimination 1 is tertiary carbon, then secondary, and then primary carbon contain leaving group in tertiary. Or we can say resonance stabilized carbocation, like as benzyl carbocation, allyl carbocation, etc. Then they undergo toward the even reaction rate. Second, nature of leaving group, good leaving group required for even reaction. And we know that weak base is a good leaving group. We know that weak base is good leaving group. Third condition, polar protic solvent. Polar protic solvent are suitable for even reaction because carbonium ion as well as anion of leaving group both are solvated in such type of solvent, or we can say both become stable in polar protic solvent. Therefore, polar protic solvent are suitable for even reaction. And next, high temperature favor elimination reaction because in which breaking of bond takes place. Therefore, temperature should be higher than room temperature. Then the substrate active toward the elimination. For example, order of elimination reaction of butyl bromides. Order of elimination, particularly even reaction for butyl bromides. Rate of elimination 1 for butyl. We know that butyl bromides are 4, namely tertiary butyl bromide, secondary butyl bromide, N-butyl bromide, normal, butyl bromide, and isobutyl bromide. First of all, we check nature of substrate because we know that for even reaction, rate of reaction toward tertiary, secondary, and primary. Therefore, first is more reactive than second because first is tertiary alkyl halide and second is secondary type. Now, third and fourth both are primary, but after formation of carbonium ion, primary carbonium ion are not easily formed, required high temperature, and they immediately show rearrangement. And as compound 4 make more stable carbonium ion than third, therefore substrate fourth is more reactive than substrate third. It means first of all we check nature of substrate. This is tertiary, this is secondary, more reactive tertiary than secondary, and both are primary. In case of primary, we check rearrangement also. Because carbocation are formed by the application of temperature, and at high temperature, carbonium ion are immediately show rearrangement and become more stable. Therefore, the rate of reaction of butyl bromide toward even reaction. Next question. Next. Rate of dehydration of alcohols toward even reaction. Rate of dehydration of alcohols in presence of acid catalyst. For example, we consider following alcohol. Alcohol first, second, third, and fourth. When these alcohols are undergo dehydration under acidic condition, therefore they first of all they make carbonium ion. Due to protonation, they make carbonium ion. For example, when this alcohol heated in presence of acid catalyst, then after protonation they change into carbonium ion, and by the loss of H plus ion, they give two types of alkene, namely 2-butene and first butene. In even elimination, Saytzeff alkene, more stable alkene, is known as Saytzeff alkene, is major product under even reaction. More stable alkene means more number of alpha hydrogen containing alkene is more stable, and this alkene is known as Saytzeff alkene. Therefore, Saytzeff alkene are major product in even reaction. For reactivity order of alcohol, we consider nature of alcohol or formation of carbocation. In case first, the carbocation is secondary. In another case, the carbocation is also secondary. In case third, the carbocation is primary. After removal of H plus ion, the carbocation is primary. And in case of fourth, the carbocation is tertiary type. And we know that tertiary carbocation is more stable. Therefore, most stable carbocation easily formed. And as fourth compound is highly reactive. Then we consider in case of secondary cation, in case of secondary carbonium cation, we consider their stability as it, not rearrangement, not consider rearrangement. Carbocation first contain 5 alpha H and carbocation second contain only 4 alpha H. It means carbocation first more stable. Therefore, the reactivity of alcohol is greater than second one. Fourth, then first, then third, and in last first, because it is prime. And first, second, third or fourth. Fourth, first, second, and सबसे least reactive compound आपके पास में third, because it is primary carbonium ion or primary alcohol. Consider another question for dehydration of alcohols. Right? Reactivity rate for the following alcohol toward the even elimination or by the acid catalyzed dehydration. Consider following alcohols. First, it is second. First, second, third. Some benzyl alcohols are there. Substituted benzyl alcohols are there. That is third and fourth. Substituted benzyl alcohols undergo dehydration reaction in presence of acid catalyst. Find a rate of elimination 1 reaction. In elimination 1, they change into carbonium ion. For example, in case of first, the carbonium ion is this. In case of second, the carbonium ion is following. In case of third, the carbonium ion is this. And in case of fourth, the carbonium ion is this. On the basis of the stability of carbonium ion, we find a rate of reaction. In carbonium ion, second, it is only benzylic and phenyl group attached with benzylic carbon. In case of compound first, the CH3 so hyperconjugation effect, and due to hyperconjugative effect, it generates negative charge at the ortho and para position 9 times, because 1 alpha H produce 3 times negative charge, second alpha H free another 3 times, and third alpha H generate another 3 times negative charge at alpha and beta or ortho and para position. Therefore, this cation is more stable than first. In case of third, only 1 alpha H is there. Only 1 alpha H is there. Therefore, its carbonium ion more stable than second but less stable than first. In case of fourth, it contains 2 alpha H. It contains 2 alpha H. Therefore, 6 times negative charge. 1 alpha hydrogen generate 3 times negative charge at the ortho and para position of the ring. It contains 2 alpha H. Therefore, negative charge. The magnitude of negative charge at ortho and para position is greater than first, then second and third, but less than first. And hence first is most stable carbonium ion, then fourth, then third, and then first. On the basis of the stability of carbonium ion, we write nature, we write order of dehydration, because we know that more stable carbonium ion will form first, and as their dehydration order is this. And after formation of cation, they lost H plus ion and make alkene. In all compound, they make conjugated alkene after loss of H plus ion. They are alkene. Yeah, after removal of water, removal of oil, change into the alkene. And these are the questions of elimination first. Elimination first reactions are suitable in alcohols in presence of acidic medium. For example, when this alcohol treated with acid H plus ion and heated in presence of H plus ion, then it gives carbonium ion first, and this carbonium ion is secondary carbonium ion. We know that carbonium are quickly, readily, so 1,2 shifting and change into more stable. And during the 1,2 shifting, methyl shifting takes place. And hence it become tertiary carbonium ion. Tertiary carbonium ion more stable than secondary. And after loss of H plus ion, it gives major product alkene. And this alkene is most stable and it contains 10 alpha H. Therefore, the major product of alkene is this. Okay. And these are the examples and explanation of E1 reaction. First, E1 reaction. For E1 reaction, substrate carry tertiary carbon carry leaving group at tertiary carbon atom or resonance stabilize carbonium ion generate. Second, polar protic solvent is required because cation and anion both are solvated in such type of solvent. Next, leaving group is best leaving group required for E1 reaction, because in step first, removal of leaving group from the substrate, and in last, polar protic and high temperature required for all elimination reactions. Okay, bye.